Assalamualaikum. This video is about discussion on tutorial chapter 4 chemical bond. So there are two tutorial for A and for B. Okay, I just choose some question for discuss. Okay, for tutorial A, for A, question number 2, show the formation of the following either ionic or covalent compound for this following compound. Okay, A is calcium fluoride. Okay, when we look calcium group 2, okay, alkyl metal, and fluorine group 17 halogen. So when metal and non-metal usually will form ionic compound. Okay, where calcium will donate electron or release electron, and another atom which is fluorine will accept electron. Okay, so when we look calcium, it has comes from group 2, so it has 2 valence electron. So we draw the valence electron. Okay, plus fluorine. Okay, 2 atom fluorine. So in the formation of this covalent compound, you must show the 2 types of atom. Okay, and then the electron donate, and then forming the compound. Okay, for fluorine comes from group 17. It has 7 valence electron. So we draw valence electron for fluorine. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, another fluorine atom, 1, 2, 3, 4, 5, 6, 7. Okay, so here calcium has 2 valence electron. 1 electron will be donate to 1 atom fluorine. Okay, here another 1 valence electron from calcium donate to fluorine, and then will form ionic compound. Okay, since calcium has been released or donate 2 electron towards 2 atom fluorine, so it has no more electron here. Okay, because has been released. So after that it will become cation, calcium 2 plus. Okay, since 2 electron has been donated to fluorine, and then here 2 atom fluorine. Okay, now we draw the valence electron. Okay, after 1 electron from fluorine has been donated, so total atom fluorine now is 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, achieve here. So since 1 atom fluorine accept 1 electron, so the charge is negative. Okay, an ion. Okay, and then you must draw bracket. Okay, this is the formation, okay, process on how atom calcium and fluorine forming ionic compound. Okay, you must show the electron donate, electron accepting, and forming a covalent compound, calcium fluoride. Okay, next is the formation of H2O. Okay, so when you look, hydrogen is group number 1, so 1 valence electron, but there are 2 atom hydrogen. Okay, And then oxygen group 16, so 6 valence electron. Okay, so when we look here, there are two atom hydrogen, another one. Okay, and comes from group 16 and group number 1, so it will forming a covalent compound sharing the electron, okay, from two types of atom. Okay, the formation is the process, okay, from each atom. Okay, so atom hydrogen has one valence electron. Okay, we draw the valence electron, and then for oxygen there are 6 valence electron. 1, 2, 3, 4, 5, 6. Okay, so this is will form covalent compound where atom hydrogen, each atom hydrogen share one electron to share with one electron from oxygen. Okay, so oxygen here will share one electron here, and hydrogen, each hydrogen will share one electron. Okay, so forming a bond. Okay, and then there's a lone pair on oxygen. Okay, so it will form covalent compound where electrons are shared between the atoms. Okay, next question is question 3. Okay, both phosphorus and nitrogen placed in group 15 in periodic table. Draw the Lewis structure of phosphorus tetrachloride and nitrogen trichloride. Okay, so since phosphorus and nitrogen group 15, so it has 5 valence electron. Okay, for example, PCl5 phosphorus tetrachloride. Okay, so phosphorus 5 valence electron, chlorine 7 valence electron. Okay, from group 17 times 5, 35 plus 5 is 40. Total for valence electron. Okay, so to form Lewis structure, the electropositive atom as central atom, and the other is bonded atom. Okay, so we arrange the atom chlorine now, 5 atom chlorine forming bonding with central atom phosphorus. Okay, so the bonded pair here, there are 2, 4, 6, 8, 10 electron. So 14 minus 10 electron, there are 30 non-bonding electron. Okay, so chlorine actually has 7 valence electron. 1 has been shared with atom chlorine, and the valence is 1, 2, 3, 4, 5, 6, 7. Okay, so each atom chlorine has 6 lone pair. Oh, sorry, not 6 lone pair. 6 non-bonded electron or 3 lone pair. Okay. So we draw the lone pair for 4 chlorine atoms. 5 chlorine atoms. Okay, so each atom chlorine has 6 non-bonded electron or 3 lone pair. Okay, so 6 times 5, so there are 30 electron. And now we look the octet for each atom. So we look at chlorine. Okay, 2, 4, 6, 8. Okay, 2, 4, 6, 8, and all octet for atom chlorine. For phosphorus, 2, 4, 6, 8, 10. Okay, for phosphorus or other atom that located in period 3 and next, for example, period 4, 5, and so on, it can be expanded octet. Okay, where it can expand the octet. Okay, more than 8 valence electron for phosphorus. Okay, because it can use their empty d orbital to accumulate additional electron. Okay, this one you can refer to notes. Okay, so for nitrogen trichloride, okay, same nitrogen group 5, so 5 valence electron, chlorine group 17, 7 valence electron times 3. Okay, so 21 plus 5, 26 valence electron. Okay, so nitrogen more electropositive than chlorine, so being a central atom. Okay, so chlorine as bonded atom. Okay, make the bonding. Okay, so 2, 5, 6 here. Okay, 26 minus 6. Left 20 for non-bonding electron. So chlorine, remember from group 7, so 1 has been shared. 1, 2, 3, 4, 5, 6, 7. So there are 3 lone pair on each chlorine atom. Okay, so now 2, 4, 6 non-bonded electron for each chlorine. So 6 times 3 is 18, right? So 20 minus 18. There are left 2 non-bonded electrons, so located here for nitrogen. Okay, plus nitrogen has 5 valence electrons, so 3 electron has been shared, left another 2, and then check for the octet. Okay, for nitrogen 2, 4, 6, 8. Okay, octet. For chlorine 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, so achieve octet. Okay, so these are the Lewis structure for both compound. Okay, next question. The Lewis structure, also write the Lewis structure for cyanide. Ka, Cn minus 1. So this is just a charge here. Okay, we'll look one by one. Carbon 4 valence electron, nitrogen is 5. Okay, remember for forming Lewis structure, we use only the valence electron, and then there's a an ion here, means there are additional 1 electron. So total is 7 valence electron. Okay, since it has 2 atoms only, so we just put here carbon and nitrogen. Okay, so make the bond, okay, between carbon and nitrogen. So 10 minus bonded electron 2, so there are left 8 non-bonding electron. Okay, so we just put on nitrogen, for example, 1, 2, 3, 4, 5, 7, 8. Okay, so we look at the octet here. 2, this one 2, 4, 6, 8. So being as double bond. Okay, so now 2, 4, 6, 8, 2, 4, 6. Okay, so carbon not achieve octet yet. So we put electron to form as another bonding, forming triple bond. Okay, and then we check the octet. 2, 4, 6, 8. 2, 4, 6, 8. Okay, so remember this one is an ion. Put the bracket and negative charge. Okay, next compound for B, selenium tetrafluoride. Okay, selenium tetrafluoride. So selenium comes from group 16, so 6 valence electron. Okay, fluorine group 17, 7 valence. So there are 4 atom fluorine times 4, 28 plus 6, 34. Okay, so draw the central atom. Okay, selenium more electropositive than fluorine, so being a central atom. Okay, with 4 atom fluorine, and then forming bonding 4 bonding. Okay, so there are actually 8 electrons here. One has been shared from fluorine and one from selenium. So 2, 4, 6, 8. 34 minus 8 is 26. Okay, 26. Then for fluorine, it has 7 valence electron. 1 has been shared. So valence 1, 2, 3, 4, 5, 6, 7. 6 non-bonding electron for each atom fluorine, or 3 lone pair. Okay. So draw all the lone pair. For Lewis structure, you must draw the atom and all the lone pair. Okay. So for each atom fluorine, it has 3 lone pair or 6 non-bonding electron. Okay, so 6 times 4, 24, right? Okay, so there are balance 2 electron, so it is lone pair for selenium. Okay. Okay, actually selenium has 6 valence electron, 4 has been bonding a share with each atom fluorine and left another 2. Okay, and then we check the octet. 2, 4, 6, 8 for fluorine. Okay, all the fluorine has achieved octet, 8 electron. For selenium, 2, 4, 6, 8, 10. Selenium, okay, located at period 3 and okay, actually selenium located on period 4. So the atom of element with located period 3, 4 and so on, it can be as expanded octet more than 8 electron. Okay. Okay, for the last one is bromine pentafluoride. Okay, the same step. Bromine 7 valence electron in group 17. Same with fluorine. Okay, but fluorine has 5 atoms. So total is 42 valence electron. Okay, bromine is like less electronegative than fluorine. So being as central atom, fluorine, there are 5 atoms fluorine, okay, as a bonded atom towards central atom bromine. Okay, so there are 5 bonding pair here. Okay, so there are 2, 4, 6, 8, 10 electron, bonding electron. So left is 32 non-bonding electron. Okay, so fluorine, each atom fluorine, 1 electron has been shared with atom bromine. So there are left 1, 2, 3, 4, 5, 6, 7. Left 6 non. Okay, so all the fluorine atom has 6 non-bonded electron. Okay, so 6 times 5, 30. Left another 2 electron. 2 non-bonded electron belongs to bromine. Okay, so octet for fluorine 2, 4, 6, 8. Bromine is forming expanded octet. Okay, and then okay, these are the Lewis structure for bromine pentafluoride. Okay, so all the valence electron here is 40 to form this compound.